So let's talk about angles of elevation and depression. So first let's look at just recognizing these angles. So let's look at a couple different scenarios. So let's say this is me standing on the ground outside, and I look up and I see a lovely hot air balloon. You've probably done this before. I'm sure you've looked up and saw something in the air, not a hot air balloon, maybe an airplane, a bird, Superman, whatever you saw up there, UFO. What you maybe didn't realize is that simply looking up at this hot air balloon created angle of elevation and an angle of depression. So before we discuss these things, we need a line that connects my eyes, my line of sight, with this hot air balloon. Let me clean this up. So going from my line of vision to maybe there's a person in the hot air balloon basket. Okay, if we recognize that if I looked straight out, that would form a horizontal line. And if the person in the hot air balloon also looked straight out, maybe they didn't look down at me, maybe they looked straight out, that would also create a horizontal line. So let's go ahead and label those as horizontals. So those are the horizontal lines of vision of me on the ground and then the person in the hot air balloon. So if I'm on the ground looking up, that creates, let's say, a 32-degree angle. The person then looking down at me would form that same 32-degree angle. But the angle from me looking up would be called the angle of elevation. So that's going from my horizontal line of vision, up to the hot air balloon, the angle of elevation. The angle of the person up here in the hot air balloon looking down at me would be the angle of depression. And in this scenario, the angle of depression and angle of elevation would be equal because the horizontals are two parallel lines cut by a transversal. So really those are alternate interior angles, so they are equal. I'll give you another example what it might look like for an angle of depression and an angle of elevation. It looks a little bit differently. So here I am looking up at an object and looking down at an object. And then I only have one horizontal here, so here is my horizontal line of vision. So looking up maybe at the sun, and looking down at my dog. Here my dog must be down a hill, so I'm looking down at the dog, which creates an angle of depression, and then looking up at the sun, which is creating an angle of elevation. So an angle of elevation goes from your horizontal and goes up, where an angle of depression starts at a horizontal and goes down. So let's try a couple of examples using trig ratios to help us solve problems involving angle of elevation and angles of depression. So number 1, suppose an airplane approaches the runway at a descent of 5 degrees, starting at 1,707 feet above the ground. Find the ground distance the plane is from the airport. So first let's draw a picture of what this would look like. So let's get our airplane, and it's approaching the airport. So if we look at the eyesight, quote unquote, of the plane down to the airport, Then if we draw the horizontal line of sight, if the airplane looked straight out horizontally. So this angle here, going from the horizontal downward, would be my angle of descent, since it's a plane, or angle of depression. So it told us that that angle is 5 degrees. Also told us that our plane is 1,707 feet above the ground. So if we were to draw that in, that would start to form a triangle of sorts. So it is 1,707 feet above the ground. And it asked us to find how far away the ground distance the plane is from the airport. So I'm just going to put an X here. So to solve for X, we need to recognize that we have a right triangle here. And we're going to use SOHCAHTOA, our trig ratios. But to do that, looking at my triangle right here, I need to know an angle. And I know my angle of depression here is 5 degrees. But I need to know this angle to be able to set up a trig ratio to solve for X. But notice, here in this corner, I have another 90-degree angle. The angle that my 5 degrees, and then this angle, my question mark, would form 90 degrees with that horizontal. So to find the question mark angle, simply take 90 minus 5. So take that 90 degrees minus 5 degrees, which gives us 45 degrees. So this angle is going to be 45 degrees. Now I can set up a trig ratio. So remember SOHCAHTOA. So let's write that out. And our first step is to label the sides. So if I look at my 45-degree angle and I go out, that I run into X, which is my opposite side, O. And then this 1,707 feet is going to be adjacent to my angle. So label it with an A or a DJ for adjacent. So looking for an O and an A, I see that TOA, my tangent ratio, is the one that I should choose. Tangent of my angle, the symbol means angle, equals O over A. So tangent, let's start plugging in values. My angle is 45 degrees equals O, which is X, over my adjacent side, which is 1,707. To solve for X, we're going to multiply by my denominator, 1,707. It's hard for me to put that in here. I'm going to write it up a little bit, but multiply that side by 1,707. And multiply this side by 1,707. Here, those two values cancel, so you are left with X equals, and just copying that down, 1,707 times tangent of 45 degrees So you're just going to plug that into your calculator. 1,707 times tangent of 45 degrees. And that should give you x equals 1,707. And that is feet. And yes, here I actually got the same answer. That usually won't happen. And I'll write feet here instead of using that little mark. Usually that won't happen. You won't have the same 1,707 feet for both sides, but in this case, it is true. All right, let's try a second one. So number 2, a firefighter on the ground sees fire in the second-story window. The angle of elevation to the window is 24 degrees. The firefighter is 70 feet from the house and his eyes are 5 feet above the ground. Find the height of the second-story window. So maybe perhaps someone's stuck in the second story and maybe they are going to bring a ladder. So we need to see how tall does the ladder need to be to reach the height of the second story window. So let's go ahead and draw a picture of this scenario. So here's my firefighter and here's the house. First piece of information it tells us is the elevation to the window. So to draw an angle of elevation, first we need a horizontal and then him looking up at the second story window. And this angle of elevation from his horizontal line of sight to looking up at the window is 24 degrees. Also, it's telling us that the firefighter is 70 feet from the house. And then also it tells us his eyes are 5 feet above the ground, but we'll use that in a second. First, let's find the length, the distance from his line of sight of the house up to that second story window. So let's solve for x, that length there. We can do that using trigonometry, SOHCAHTOA. So let's label these sides. Looking at my angle, x will be the opposite side, so I'm going to put an O there. 70 is the adjacent side. Hypotenuse is not labeled, so we're not going to label it either. So then you're going to write SOHCAHTOA. Which one includes an O and an A? It's going to be tangent. So write out that trig function, trig ratio. Tangent of my angle is O over A. Let's start plugging in. Tangent of my angle, which is 24 degrees, equals opposite, which is x, over adjacent, which is 70. Looking over here, x and 70. To solve for x, multiply both sides by 70. Cancels on the right side. Just leaves me with x equals, grab your calculator, put this in your calculator, 70 times tangent of 24 degrees. That should give you 31.2. That's going to be feet. That is not our final answer. That's where this 5 feet comes in. So that's the length from his line of sight horizontally to his line of sight up to the window. But we also need to include this distance here. So this distance here is where that 5 feet comes in. So think of it from his toes to his eyes. That 5 feet is what that represents. So just take that 31.2 and add 5 feet. Then you'll have your final answer, 36.2 feet.